So after covering discrete random variables, including its PMF, CDF, and all their relationship, we are ready to talk about expectation. So I'm sure you have heard about the term one way or another in the past. And sometimes we call it average. Okay, sometimes we call it mean. Okay, more formally, people call it expectation. It's sort of like what is the value of this random variable can take on expectation or expectedly. Okay, so we're gonna phrase everything in terms of discrete random variables because we know the PMF, the CDF, and how they work out. Okay, but later on when we go to chapter 5, we will see how to define expectation as well in the continuous case. All right, definition: the expected value or mean or average of a discrete random variable. So notice that we highlight here, this works for a discrete random variable, is defined to be, so the notation here, we use a capital E, okay, to represent the expectation, okay? And we typically use a bracket or parenthesis of the random variable inside to represent it's the expected value of random variable X, okay? So mathematically, what that is doing is that we are multiplying with the possible value, like any value, any possible value of the capital X, okay? Multiply that with the PMF evaluated at this value. So PMF, if you remember, so eternally, we can also write it over there. We take the product of the two, and then we sum that over to all of the possible values that X can take where its PMF is positive, okay? So it could be that, remember, sometimes we could have a PMF evaluate at a certain point equals to 0, because if that is the case, then this whole PMF value becomes 0, so that term goes out of the summation. So that's why we really just talking about looking at the possible values of capital X, like among all of the small x's over here, that is having a positive probability, okay? So equivalently, because this is the PMF, right, evaluate a small x, so we can always write it over there as well. So the way to understand it, okay, it is a weighted average of the possible values, small x, that the capital X, which is the random variable, can take on, each value being weighted by the probability of px. Okay, so in English, plain English, that's what we understand, okay? And mathematically, we do have an expression for the expected value for a discrete random variable, so we can always go back to this definition when we're trying to figure out the expectation for a particular random variable, okay? And also, since people are talking about like average, mean, and expectation, there's a joke that when she told me I was average, she was just being mean, so I was just hoping to share that with you all. Oops, let me clear that up, okay? So let's look at example and try to find its expectation, just to make sure that we know how to work it out using the expectation definition, okay? So X is the outcome when we roll a four-sided fair die. Find the probability, find the expectation of X, okay? So just to get us started, okay? Expectation of X based on the definition before, okay? It's looking at all of the possible, right? The PMF is greater than 0, and we're having X times PX, okay? X is the value of, so all of this is small x, okay? Except for this one, this is capital X, okay? So, and here small as well. So small x here is the value, each of the possible values, which is one of the 4 values that can take, right? And then this PX, remember, is the PMF, okay? So let's, if you are so familiar and comfortable, you can just proceed this way. But if you're worried about, or like just trying to want to make sure that you get every piece correct, maybe one thing we could do just outside of the equation over here is just to show that, well, the PMF evaluated at all of the 4 possible values, they're the same as 1/4 because it's a fair die, okay? So if I follow this, okay, what this gives me is that, okay, I'm looking at all of the possible PMF values, right? So it's going to be 1, 2, 3, 4 over here. So if I follow this directly, what this does is I'm doing 1 times, right? 1/4, because my first possible value is 1, and it's P, and the P1 is 1/4. I do that with 2. I do that with 3, and then I do that with 4. Okay. If I do it, it's going to be 2.5 or 10 over 4, okay? So what this is saying is that if I'm looking at the outcome of rolling a 4-sided fair die on expectation or on average, if I'm doing this for a large number of times, if you think in that way, then my expectation of this outcome gonna be 2.5 or 10 over 4. Okay, so keep that in mind, okay, how you're able to utilize the definition of the expectation of a discrete random variable, and then you're able to proceed with particular scenario.